Okay guys, we're going to have a look at this question in your carboxylic acids notes. Question that every year causes students a little bit of difficulty, probably because of some of the unfamiliar units which are used within it. But if you think logically about it, it really shouldn't cause you any major diffs. So we'll have a look at it now, and I'll try and explain it as best I can. So first thing that we'll do is we'll just write the molecular mass of that, which is 105, sorry, oops, first mistake, 102. Okay, and we'll come back to that later on, alright? Right, so let's go through this question and see what are the key points that we need to have a look at. So we're calculating the concentration of isovaleric acid in moles per decimeter cubed. So we're looking at it in moles per decimeter cubed, okay, of air. Alright? If 5 microliters are vaporized in 80 decimeters cubed. So we're looking at it here in 80, but we've got to eventually end up with it per 1 decimeter cubed. Okay, the density of the acid, which is a liquid, okay, so that's important, it's 0.95 grams per cubic centimeter. So just to remind us that mass equals density multiplied by volume. Okay, so we need to get from this value here into moles, which is here. So how do we do that? Well, we are in, currently this is obviously a volume. How can we go from volume to mass? Indeed we can, because if we take the volume and we multiply it by the density, which is in this instance 0.95, we will indeed get mass. Can we then go from mass to moles, which is obviously what the examiner wants us to get to up here? Well, yes, of course we can. Moles, very simply, GCSE double word, is equal to mass, which we've just calculated out up here, divided by the RFM, which I worked out at the start, knowing full well that I would need it at this stage. Okay, now that will give us number of moles, obviously, but remember we haven't changed this at the minute from the 5 microliters. We've converted that 5 microliters the whole way through into number of moles. So that would give us moles per 80 decimeters cubed. Okay, but therefore our final answer, so our answer, whatever we get there, which is going to be per 80 decimeters cubed, we then need to divide it by 80. So let's start this. Now, we've got 5 microliters, okay, and 5 microliters is 1 times 10 to the minus 6 liters. Now, why do they give us that? Well, first of all, our density is given per cubic centimeter. So I need to take my 5 microliters and I needed to convert it into centimeters cubed. So 5 microliters is the same as 5 multiplied by 10 to the minus 6 liters. Okay, that's simply the 5 microliters. 1 microliter is 1 times 10 to the minus 6. Well, 5 microliters is 5 times 10 to the minus 6. So we have 5 times 10 to the minus 6 microliters, and if we want to go from liters into cubic centimeters, well, 1 liter equals 1000 cubic centimeters, so therefore we take that value and we multiply it by 1000. So if we take 5 times 10 to the minus 6, multiply it by 1000, obviously we bring that 5 times 10 to the minus 3 centimeters. Now that's a very small volume. Okay, now so we can now take that and we can convert that into mass, because each of those centimeters cubed are 0.95 of a gram, and mass equals density multiplied by volume. So that gives us therefore a mass of 4.75 times 10 to the minus 3, and that's in grams. Now we've got our grams, so therefore we can work out number of moles. N equals 4.75 times 10 to the minus 3 divided by the RFM, mass divided by RFM, equals moles, and that gives us a very small number of moles of 4.657 times 10 to the minus 5. Okay, and that's N, number of moles. So that is number of moles, but if you remember, that is number of moles per 80 decimeters cubed, because we haven't done anything with that yet in terms of the 80 dm cubed. So how do I get it then to number of moles per 1 dm cubed? Well, if that's moles per 80, fairly obviously we simply divide that by 80, and that tells me that I have 5.82 to 3 significant figures times 10 to the minus 7, and the final units are indeed moles per 1 decimeter cubed. So hopefully that is of some use to you to explain that.